excited. I'm so excited. Okay.
So this is basically just a tutorial on how to make a rotor blade for helicopter work in ANSYS Fluent. I don't know if you could hear, but there's music in the background. You should follow SheepOW on Twitch, by the way. So I'm gonna open up Design Modeler so you can see kind of how I did it. Alright, so I designed this helicopter blade in the one that's right here. I designed this blade in Fusion 360, and so I created a revolve. I created a cross section of this and revolved it around, and this is the rotating volume that's rotating inside of my medium, which is this giant cube. Then you can go to this mesh, which I think I already have open. I have the mesh open. So I can unsuppress these bodies. But so what you want to do is for the mesh settings, at least for my particular blade, this is what so I used a 0.2 meter element size captured curvature
Dude,
with a
I'm so
minimum
fucking mad that I just fucked that up.
element size of
I'm so mad I'm gonna go pee.
2 millimeters. Then the face sizing, I used face sizing on the let me find it. Okay, so I need to hide this body. Alright, so I used face sizing on um these faces, which you can select going into the single select, change that to box select. And what you need to do is you need to hide each surface. And then after you've hidden each surface except for your blade, you want to drag over it. And you're going to go to Mesh, right-click, Insert, Sizing.
I'm gonna do a whole fucking
And
different
then
song.
you use that select for the face sizing.
How's the video going, Elliot?
Yeah, I definitely spelt that wrong, but um, this is an engineering tutorial, so um, so this is so you're gonna select that blade, have it do face sizing.
I'm glad. Oh yeah, to the point.
The element size
Video. That's
is
so good. I'm
uh
so glad. That's
a centimeter, and then the local min size is 4 millimeters for that face sizing, and that's just to capture enough detail, like make the blade, otherwise it doesn't mesh.
Ooh.
Then I did body sizing of this to give this
You know
more
just because you're here and you told me
elements.
you liked Mitski one time, so now I associate you with Mitski because you're the only person that's told me they like Mitski. So yeah, you're the only person I associate with Mitski. So now you are Mitski to me in my brain. So now I'm going to play a Mitski song for you, and you must love it because otherwise, my brain will break. Well, actually, you don't have to love it. That's not a part of the brain breaking part.
So I used body sizing for this. if you can't hear the stream in the background, then this probably won't really make any sense for you. But so I use body sizing why I'm like taking breaks. For the body sizing, I just did 0.2 meters, and that's just to
I want to
try
meet Mitski.
and limit some of
I
the
saw her do this
issues.
thing on a on a Tiny Desk concert. Have you seen her Tiny Desk concert? It's very good. Um, where she sang into the like. I don't have my guitar near me, but she sang into the as close to the strings as possible, and her voice then played through the strings and through the amp, and it made that's fucking crazy. That's smart. That's fucking smart, and so fucking cool. Yeah, that's sick as fuck, right? It's super sick. Like holy shit. And she's playing chords while doing it, so it was like modulating her voice, I think. I don't know. Was it? I have to watch that again. Because if she was modulating it with the chords, that's fucking crazy. Anyway, she bops though. I want to meet her. I want to have lunch. You think she does lunch? Nah,
Right.
not with nobody.
Back to the tutorial.
I don't know why, but I just see her as like a like an Artemis like god that just does nothing but play like really cool punk music all day. That's how I picture Mitski in her day to day life.
That is probably true.
I kind of
Okay.
just left Jay and I feel bad, but I'm gonna come back to him in like 3 seconds.
So body sizing is about 0.2 meters. And I did that because of I wanted to increase the orthogonal quality because I have a couple elements that are really low, and if I left that as is, I would have more elements, I'm pretty sure, that would have low orthogonal quality if I just let it be sized the same as the entire mesh. Then I did edge sizing, which I did on the edge, the trailing edge of the blade, and I did that because it helps with the quality of the mesh, because ANSYS has a hard time doing sharp corners. So um, it's a lot easier for it. It's not easier, but it improves the quality of the mesh if you do a finer mesh size on the trailing edge of the blade.
My God, I'm so lonely. So I open the window. Okay, I gotta find the right key.
So for the edge sizing, I just did that as a flat 2 millimeters, and that worked for my mesh. But it just helps around this trailing edge.
I'm so lonely.
Then for the I named the selection, so the same way I did the box select earlier to select it for face sizing, you do that the same thing for the blade. And then I put an inlet and outlet on the I selected it with this face select on the on the z-axis because that's where my blades spin, so I have an inlet and an outlet that I labeled, which will be automatically generated when I go into Fluent to do the setup. So those were my settings for my mesh.
I feel like I knew how this song goes, but I'm not recognizing Lee's lyrics.
And then you can go into Fluent.
I know the second verse better.
We'll
get there.
And so I'm using the realizable K epsilon model, just with the base thing, the base like numbers. This is for a turbulent, for a flow that if you're not sure if it's turbulent, it differs from K omega. K omega is more for when you have flows near the walls, near like the boundaries. So that medium is like a room, and if I cared about that, I'd probably use the K omega. But I want to take it far away from the wall because I just want it to be open space, basically. And the fluid is obviously air. For the cell zone conditions, you have the medium and the rotating disk. The rotating disk is rotating about the z-axis. It has a rotational speed of 1200 RPM, and it's speeding at, so I changed that into radians, which is 125.66. You want to put that to frame and mesh motion and apply that, which I should probably mention up here for the general information. What you want is a pressure-based transient. So after you have the rotating disk at whatever you need, you can set your inlet velocity. I had my inlet velocity at 0 because it's not like, it's really meant to be just outside, not actually have an inlet. The outlet is just a pressure outlet with standard atmosphere. For the initialization, I just did a hybrid initialization. And then I
wasn't even me this time.
Ran the calculation with 20 time steps with a time step size of 1 and 20 iterations per second. When it got to like, it seemed to be pretty stable, so it reached, you know, like the 1200 RPM. And so I calculated the lift force, which you could do it from the sidebar over here, but it doesn't really make a difference to just look it up here rather than go through that. You can just look up lift, and it tells you the path that you could take over here too. And you want to select your blade. That's the reason you made that named selection of the blade earlier. You can select your lift force. I have lift in the Z direction because that's how my blade is oriented. So I would make this vector be in the Z direction, which would not be 2, that would be incorrect. And you can choose either lift coefficient or lift force. It's the same situation for the drag force. So I still have a low quality model for the blades, a low quality mesh, so I'm trying to fix I'll probably try to fix the mesh in the future, and I'll post more information and have a better tutorial that isn't me just kind of throwing this together in the future if anyone has any problems with this tutorial, which you definitely probably will. But I just have a low orthogonal quality. It took a lot of time to get to this point, and so if this is really for myself, just to remember what I did, because it's
That's what I was doing earlier.
really hard to remember after doing this like
fucking so sick.
50 times. And so that's basically all I have for now. I'm going to, in a future video, when I figure it out, I'll export the forces into ANSYS mechanical and do some analysis with that. That'll be coming in the future. The reason I said I made this for myself is just like, this isn't really a good tutorial, it's just to remind me of all of the stuff I've been doing. If anyone has any questions about this, you could ask it in the comments, and I'll do my best to answer, because I know how annoying this is to have to do with 0 experience and no knowledge of how to use Mesher, Design Modeler, or Fluent, because I had no knowledge of how to do that. So obviously there's people that are more experienced at this than I am. But if I couldn't find anything for modeling helicopter blades, if you want a good direction to go, you want to look at propellers and like basically what I did was I did pretty much the same thing you do for a propeller, but I did it with a helicopter blade. The biggest issue, the biggest like the hardest thing is the mesh. Also, sorry that I just bumped my mic. That's probably loud. That's it. I don't know if you could hear the music in the background, but I'm gonna leave that if you can because I'm not good at using OBS. That's the end of the video.
Venus, planet of love, was destroyed by global warming. Did its people want too much? Did its people want too much? And I don't want your pity, I just want somebody near me. Near me. Need more water. My God, my God, I'm so lonely. So I open the window to hear sounds of people. This is like my old voice. Like, this is how lovable. That's weird. It's kind of fun to go back to, though. My God, I'm so lonely. So, Jay. Okay. My God, I'm so lonely. So I open the window to hear sounds of people. To hear sounds of people. Venus, planet of love, was destroyed by global warming. Did its people want too much? Did its people want too much? And I don't want your pity, I just want somebody near me. Guess I'm a coward, I just wanna feel alright. And I know no one will save me, I just need someone to kiss. Give me one good honest kiss, and I'll be alright. I see. I should do that. So it goes. Nobody, 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 no. Okay, wait, how should I do it? Nobody, nobody, no, nobody, nobody, nobody. I've been, I've been big and small, and big and small, and big and small again. Still nobody wants me, still nobody wants me, and I know no one will save me. I'm just asking for a kiss. Give me one good movie kiss, Nobody knows. Nobody, nobody, no. I can't get this part. I can't get this rhythm. Thank you, Elliot. Do you like that song? Jay, type in a rhythm so that I can play to it. What is a shit rhythm? Well, you tried for like 2 seconds. That's not how you gotta go long. Rhythm doesn't have to be complicated. Yeah, you just need to get your ideas out because you little ADHD fuck. I don't know why I'm so aggressive to you about it. It's like I'm calling you like a dirty slut. Like, yeah, I bet you can't fucking pay attention in class, can you? Yeah.
We're gonna end it there.
I can hear the tilt in your breathing. Mhm. I was just guessing, but now you told me.